The index of refraction varies in proportion to the wavelength of light. So for materials shot with wide-angle lenses, there may be chromatic aberration resulting from the difference in the focal lengths of the primary colors red, green and blue. This phenomenon can be simulated in Mystica by combining different effect clips. We can take any clip and separate the RGB channels and process them individually. To do this, use the channels effect and with the operation parameter of the red channel define out as 0. Copy the parameters of the red channel and paste them in the green channel. This way, the information of the blue channel is isolated. In the timeline, we make 2 copies of the workflow and separate the other 2 channels by pasting or deleting as appropriate. The red, blue and green channels are now separated. We recompose the 3 channels using a Comp 3D. In Options, we define the background as No. And for Layer 1, we set the Blend attribute in Linear Dodge mode, which is the mathematic function add. Copy Layer 1 twice and name the layers with the name of each channel to identify them easily. The channels are now combined in a 3-dimensional space. I'll move the layers here to see them better. Returning the layers to their original position, we can start to deform the green channel with Sil angle in order to see the cylindrical deformation in the horizontal. The recommended value for the green channel is -0.1 and for the red channel it's -0.2. Now, with one of the axes, we make big adjustments to the scale of the depth of the composition with the parameter size Z. The deformation we see in the green and blue channels is clear to see, but it produces a problem of superimposition in the 3D space. To avoid this problem, move the green channel 0.5 units of position Z and the red channel 1 unit of position Z. By scaling the axis in size Z, the channels do not cross in the 3D space. The aberration effect will always be more visible at the edges of the image than in the middle. To perfect the effect, add a distortion in the parameter TOR-ang. In the green channel, only -0.05, and in the red channel, -0.1. The channels will have crossed again in the 3D space. To rectify this, simply move the red channel a little forward, by 1/100th of a unit, defining position Z as 0.11. The deformation of the channels will now be spherical instead of cylindrical, as occurs in lenses. In the timeline, we now replace the original clip with dummies, and by grouping the workflow, we create a template. We can perfect this effect by adding blur to the edges of the image. We can create the mask quickly with an RGB correct. Use an elliptical window and export it as a mask, viewing it in the red channel. We should invert it with WinInv. In the timeline, add a blur effect in RGB Rad A mode using a circle type blur. When increasing the radius of the blur, we note how only the edges of the image are affected. With the RGB correct, we can adjust the blur window to our taste. If we view the result of the template, we see that the channels respect the alpha channel generated. To avoid this, add the effect Clear Alpha to the blur in the timeline. The template will now function correctly, allowing us to continue adjusting the radius of the blur, its window, or the degree of chromatic aberration via the parameter size Z of the axis within the Comp3D of the template. Finally, rename the group so the new effect can be easily identified.